Saxon Algebra 1/2, Lesson 7, we are going to review. I'm presuming that you already know this. You know how to multiply and divide decimals, but there are a lot of fussy little rules with decimals, so we are reviewing them. And that's really a big part of what we're doing here at the beginning of this 1/2 level is we're reviewing fractions, decimals, and percents, because they are tools that we'll be using throughout your study of mathematics. However far you go in math, these will always crop up in your work, even in calculus and advanced algebras. Trigonometry, there's this all the way through. So these are kind of the basic language of math, and we want to make sure that you're really solid in those. John and I do, before we build more. So that's why we're reviewing this so heavily. We've already talked about adding and subtracting decimals. And the rule there, as I'm sure you recall, is we need to line up the decimal places. Right? They have to be centered perfectly over each other so that the ones are in a column, the tenths, the hundredths, the thousandths. We need to make sure everything's lined up perfectly. When we're multiplying, that rule does not apply. And I don't know about you guys, but I love a rule that looks like this one. Step 1, ignore the decimals. I'll give you a second to write all that down before I talk again. So when we get a multiplication problem for decimals, the first thing we do is ignore the fact that they're decimals, and we just multiply them as if they were normal numbers. So let's look at an example. It's always easier to explain with numbers instead of words. So showing you how the numbers behave is the most important thing that I can do. John writes the problem like this. He writes the multiplication problem out in a line. That's not helpful. It's never helpful. John does it that way for his own reasons. But I will always take the numbers and stack them, right? I bring this one and I write it underneath. Then what I like to do, if you're doing your homework, don't even write it down the wrong way. Just write it like this. I write it the wrong way just to show you how it's going to be in the homework. But if I ever write it down and change my mind, just put a little line through it. Do not erase. Do not waste your time erasing when you're doing your math. It's a waste of time. It's a waste of effort. It breeds perfectionist attitudes, and none of that is helpful. So just draw a simple line through it. Don't scribble it out hard. Just cross it off gently. Okay, and then I've written it down here. Now what we're going to do is ignore the decimals and multiply like normal. Okay, we go over here and we start. 2 times 2 is 4. 2 times 1 is 2. 2 times 4 is 8. I'm going to make my columns really distinct. I'm going to put lots of extra space in there because multiplication can quickly turn into a jumble. Now I'm ready to multiply with the 3. My first product is going to go here, so I put a 0 over here to remind myself that I'm actually multiplying by 30, not just 3, because this is the tens place. Okay, here we go. 3 times 2 is 6. 3 times 1 is 3. 3 times 4 is 12. So far, so good. One more. Now we're here at 6. We put in 2 zeros because this is technically 600. The first product will go below the 6. 6 times 2 is 12. It's the first time we've had to carry a 1. 6, 7. 6 times 4 is 24. Okay, we've done all our multiplying. And now the next step in a normal multiplication problem is we add up the products, right? 4, 8, 13, 10, 6, and 2. Okay, so this is the number we get. Now we're ready for step 2. And I'm just going to call it add the decimal, add in the decimal. And because this is too hard to explain in words, you'll understand what I mean. We go back to the factors. I'm going to make these decimals big. And we count how many digits are behind the decimals in the factors. 1, 2, 3, right? There are the decimals, and that's the number of digits we have that are behind the decimals in their own numbers. 3. Then we go to the answer and we put the same number of digits behind the decimal in our answer. So it needs to be 3, 1, 2, 3, so the decimal goes there. So our final answer is 260 and 384 thousandths. Did you hear the TH at the end of my word? It's really hard to say without sounding ridiculous. Thousandths. That's why mathematicians don't use that style of saying it. We would say 260.384. Remember, you can't say, the wrong thing to say is 260.384. No, unless you say 384 thousandths, you can't call that 384. You can say 260.384. Yay. Happiness. Okay, let's do one more. Flipping. I'm in the creaky chair again. It creaks every time I stand up and sit down. And I always stand up when I turn the page to make sure that my book is still in frame. And my chair always squeaks. Okay, multiply. This is how John writes it. Again, you don't have to do this. 6.78 times 0.0537. Okay, now, normally what I do is I just leave the first one in place and I take the second one and write it underneath, and that's fine. What some students think is, I like to put the bigger number on top. So you may think that, and that's perfectly valid, perfectly fine. If you look at these two numbers, you'll see this one has 3 interesting digits, and this one has 3 interesting digits. These zeros don't interest me much. So in some ways, they're kind of the same size, but you can put this one underneath or you can put this one underneath, whichever you rather. So just to mix it up, I'm going to leave this one and I'm going to write 6.78 there, right? It'll go like that. Then I'll squiggle this out because I don't need it anymore. And I'll multiply like that, just for fun. You can do it either way. It does not make a difference. I am going to make my decimals really bold. Okay, ready to start multiplying. 8 times 7 is 56. 8 times 3 is 24, plus 5 more is 29. Ooh, I'm sorry, I wrote that over too far, but it's okay. 42. And then those are just zeros, so there's no need for me to write zeros out there. I can just ignore it. Okay, the 7 is actually a 70, so I'm going to put the 0 down. 7 times 7 is 49. I cross off my old borrowing. I should cross them both off. I'm going to carry the 4. 49, right? Then this is 21 plus 4 is 25. And 5 times 7 is 35 plus 2 is 37. Okay? All my old ones I'll just squiggle out so I don't get confused by those. And now we're going to do the 6. 2 zeros because it's actually 600. 6 times 7 is 42. 6 times 3 is 18 plus 2 is 22. 6 times 5 is 30 plus 2 more is 32 again. Okay, now we're ready to add. 6, 18, that becomes 10. That's 14. All right, that's a big number. We need to put the decimal back in. Remember, our rule is we go back and we count the number of decimal places in the factors. Remember, the factors are the two numbers we multiply together. Product is the answer. We count the number of decimal places we count the number of, yeah, you can say that, that makes sense. The number of decimal places in the factors, 1, 2, 3, 4, 5, 6. And then we make sure that we have the same number in the product, 1, 2, 3, 4, 5, 6. Whoa, the decimal's gonna go all the way there. Okay, so the answer is 0.364086. If you want to, you can put a 0 there in the ones place, just to show that there's no larger digits in this, non-zero digits. This is not necessary. I would accept that as a perfectly valid answer. John usually puts that 0 into the ones place. It's fine. If you think it looks better, go for it, but that is correct. Okay, there's our practice on multiplying decimals. Now we're going to do the dividing. This is where it really gets dramatic, you guys. And I'm just going to dive in. I'm not going to try and summarize these rules. I'm just going to show you in each case what we need to do. 0.084. Okay. Once again, John's given us a format that we can't use to actually do the work. So this is the way it's written in the book. You can change it and copy it the way that it's useful. Remember that this says 0.084 divided by 0.35. The way we interpret that is we write 0.084 and we put that in the division box divided by 0.35. Okay, so the first number goes in the box, the second number goes on the outside. Sometimes that's just confusing. All right, now with division and decimals, we have to deal with the decimals on the front. It's not like multiplication where we can ignore them. The first thing we do is we look at the number on the outside of the box and we say, does it have any decimals? Dang, yes it does. So what we have to do is we have to essentially multiply by 100. That's what we're doing. We're going to talk about that some more in the next lesson, about how we move decimals. But we're essentially jumping it twice to get it at the end of our number. If we change this number by 2 jumps of a decimal point, then we have to move this one too. 1, 2. Okay, so this is where the decimal place is going to move on this number. So we've essentially multiplied each number by 100. 2 jumps of the decimal place. Now our decimal is right where we want it. This number still has a decimal in it, but that's okay. When we have a decimal inside the box, we just put it right up there in our answer. Beautiful. Now we're ready to multiply, and we can go right ahead we're ready to divide, and we do it just like we ordinarily would. We say, how many times does 35 go into 8? It doesn't. How many times does 35 go into 84? I can see that's going to go in twice because I know that 2 times 35 is 70. And that works nicely. I get 14. Now, because we've established our decimal place in the division, we can bring down zeros all day, right? Because there's an infinite line of zeros. Lord, I hope we don't need that many. But I can keep bringing down zeros all day long as I want to. So I'm going to bring down to 0, and I'm going to ask, how many times does 35 go into 140? Well, this gives me a really great clue. If 2 times 35 is 70, then 4 times 35, I bet, is 140. Let's try it. 20. 12 plus 2 is 14. There it is. So it comes out even. 4 times 35 is 140. I subtract, I get 0. I don't need to bring anything more down. And my answer is 0.24. Again, I can write the lead 0 if I want. I don't have to. I'm going to do it this time. I'm going to stop doing it because I normally just write 0.24, and that's perfectly fine. Okay, so what we learned here is that when there's a decimal in the outside number, you have to bump it till you get it to the edge of the number, and then you have to take the same number of bumps inside and then put the decimal straight up from there. Okay, let's do another one. There are quite a few examples in this section because there are so many different ways the decimals can show up. Again, I'm going to write it the way the book has it, just to remind you how to set it up. 21 divided by 0.5. All right, 21 goes on the inside. 0.5 goes on the outside. We look here for a decimal first. We see, okay, we've got one, we need to jump it once. All right, there's the decimal, but there's no place to jump. So we put in a 0 so we can jump it once, and it'll go right up there. Okay, 5 goes into 2, not at all. 5 goes into 21 4 times. 5 times 4 is 20. We subtract and get 10. 5 goes into 10 exactly twice. We come out even. And so our answer is 42. You can write this number as 42 with a decimal, or the number could be written like this. We already have the decimal because we put it in as we were taking care of things on the front part of that problem, but this is another way to say the same thing. 7.5. Divide 31 by 8. Remember that this always says divided by. That helps us see what the problem is doing. 31 divided by 8 is going to look like this, right? Okay, I don't see any decimals in either one of these problems, so I'm going to ignore that. 8 into 31, well shoot, 8 times 4 is 32, but that's too big, so it's going to have to be 8 times 3. That's 24. I subtract and I get, what, 7. 8 into 7. Now, sometimes we just say, oh, remainder of 7, but we're not doing that now. We're going to go ahead and divide it out to get a number with decimal places. So what we have to do now, we want to bring down a 0, but before we can do that, we have to put in the decimal, both in the number that we're dividing and in the answer. So I add the decimal. Now I can bring down a 0. 8 into 7. Well, 8 times 9 is 72, so that's too big. 8 times 8 will work. 64, we subtract 6. I'm gonna bring down another 0. You can write them up here if you want, but you don't have to. You can just keep adding them here. 8 times 7 is 56. Will this ever end? Bring down another 0. Oh, and the answer is yes, because 8 times 5 is 40 exactly. So we're done. All right, so our answer here, even though our original numbers didn't have decimal places to worry about, our answer, our quotient, does have decimals. We had to add a decimal in the middle of that problem to get it to come out. It said, and we knew to do that because in the book, it says, write the quotient as a decimal number. That means don't stop and just write remainder, keep going until you get a decimal number. So that's what we did. Here it says divide and round to 2 decimal places, and then there's a big number. Now, remember that if we're going to round to 2 decimal places, we actually need to calculate 3 decimal places because that third number will tell us whether to stay or to round up in the second decimal place. I'll show you what I mean. Flip the page. Creak the chair. Okay. This is example 7.6, and look at the number, it's really long. Okay, I'll make the decimal places big so you can see them. All right, this number goes in the box, this number goes out of the box. 0, 0, 0. Okay, so I'm recopying. Again, you don't have to write this on your page in your homework. You see this in the book and go, oh no, I'm gonna write it properly. Okay, that fell off the line. All right, so I look here first. I see a decimal, so I go, okay, well, I have to move it 1, 2, 3 places to get it where I want it. 1, 2, 3 places there as well, and then it'll go in the answer right up there. Okay. So, 32, and I've skipped past these zeros. 32 does not go into 4, but 32 goes into 44. I can do that once. 1 times 32 It's 32. I subtract, I get 12. All right, well, 32 doesn't go into 12. So I bring down a 1. Remember our steps for long division. I should have told you this. Our steps are estimate. That's the hardest part. Multiply. Subtract. And bring down. And we do that over and over and over. That's called an algorithm. It's a series of steps that we repeat. And that's the long division algorithm. Okay, so we figured that out. Now we've got a new number we brought down, and we're trying to figure out how many times 32 goes into 121. Well, I look at the 3 and the 12, and I go, oh, 3 times 4 is 12. That's pretty cool. That might work. But when I look at the 2, I go, when I multiply that by 4, when I do 32 times 4, it's going to get too big. It's going to be 128. Shoot. So my estimating tells me 4 is too big. I need to stay with 3. Now I multiply. 3 times 2 is 6. 3 times 3 is 9. Now I subtract. And now I bring down the 5. Okay, now I'm reminding myself, what am I trying to do here? Oh yeah, we're trying to divide this and round to 2 decimal places. And that tells me I actually need to calculate 3 decimal places because I need 1 digit to tell me how to round the second decimal place. So this isn't enough. We have to do 1 more, but just 1 more. How many times does 32 go into 25? It doesn't. But I see, well, 3 times 8 is 24. That looks like it might be good. Let's see what happens if we do 32 times 8. Is that what I said? Yes. 6, 24, 25. Oh, you guys, it's just 1 too big. 8 is too big. So this needs to be 7, right? 7 times 2 is 14. Carry the 1, 21, 22. Okay, so this number works. I don't have to keep going because I've got my 3 decimal places, right? And so now I'm not going to keep going. It's not necessary. It says to round to 2 decimal places. We've got 3. So I circle this one because that's the one that's either going to stay or go up. This number tells me which one to do. If the number is between 0 and 4, I stay. I slay. No, I stay. And if it's between 5 and 9, I go up. Those are our rounding rules, right? This is a 7. It tells me to go up, so my answer is 0.14, rounded to 2 decimals. Yay, that's the right answer. Okay, one last topic that really doesn't even have an example with it. We just want to talk about estimation. Sometimes when we're working with decimals, it's easy to make mistakes because the numbers are so crazy when you have all these decimal places, right? So what we can do is just take a quick look at a problem and see if it makes sense. I'm going to look at the practice problems because John does not show examples of this. All right, so I'm helping you do part of your homework. In the practice set, the practice problems, in part A, we have this problem, 2.14. Okay? John asks us to estimate and then evaluate. So what that means is first we're going to take a guess at what our number is going to be, and then we're going to actually do the multiplication. What we do to estimate is we round to the closest whole number. So this would become 45, right? Because this 6 tells me to round this digit up. And then here, the 2, I'm going to leave it as 2 because that 1 tells me to leave it. So by rounding it, I estimate that my answer is going to be about 90. Okay? So that's what John means when he says estimate. Round them to the closest whole number and do the multiplication so that you can get kind of a baseline. Then when you go through and actually multiply, which is your next step, that's what evaluate means, you'll see if your answer comes out close to 90, and I bet it will. And then I'll do part B for you as well. Estimate and then evaluate. It's 5.22 times 0.064. Okay. Same thing. I'm going to round this to the closest whole number, 5, and the 2 tells me to stay at 5, right? It's in that range. So this is 5. Now this one's trickier because we don't have a whole number at all. So I'm going to multiply just to round the first significant digit. So I'm rounding this one. In this one I rounded this one and I used that number. And in this one I'm rounding this one and I'm using that number. So this tells me to leave it at 0.06. Now I can quickly do this calculation. 5 times 6 is 30, but I need to have 2 digits behind the decimal. So this tells me that my product should be somewhere around 0.3. And if you were to do the actual multiplication, then you would compare your answer to that and see if you were in the ballpark. All right, so that's how you estimate. Those are the practice problems that are assigned to this lesson, and I've showed you the first part of those. Remember that when you're doing the actual practice, you'll estimate, and then you'll do the actual multiplication too. Okay, that is it for lesson 7. Thank you. I hope you enjoyed this lovely decimal review, and I will see you next time.